Hello. This is going to be a walkthrough of Activity D in Unit 6, so Activity 6 D. This one is called Spreadsheet Energy Graphs, or sometimes just called Energy Graphs. Now, since we've started using Desmos a lot more, what that means is we haven't been using spreadsheets quite as much. We used to use them for graphing instead of Desmos, and so at this point in the year, people would be a lot more comfortable with them. Since we've been using Desmos more, we haven't had as much spreadsheet work, so I'm going to go ahead and walk through a lot of the basics on this one. If you're already comfortable with spreadsheets, feel free to jump ahead, fast forward, play this at 2 speed, whatever it is you need to do to kind of get through. You can also scan the slides for the basic directions. So first, let's do a quick intro to spreadsheets. A spreadsheet is a bunch of different calculators. I think we did a spreadsheet intro way back when, but each of these tiny little boxes is called a cell. And if you do something like equals on, let's say, 3 times 4, it can do that calculation. Now, it can do that in every single cell, so it can run hundreds, if not thousands, or millions of calculations all at once. And there's even some fancy functions that you can do that if you want to know more about, let me know. I'm happy to send you some old tutorials and other things. But essentially, we're going to be using the fact that each of these boxes is a calculator to do some calculations and then to do some graphing. So let's go ahead and get started with that. So what we're going to be doing in this one, it says step 1, use a spreadsheet to calculate GPE, so that's gravitational potential energy, kinetic energy, and total energy of a 5 kilogram object thrown into the air. Now here we can see we have a column for GPE, we have a column for kinetic energy, and a column for total energy. We've provided the velocity at different heights. Notice that over here are our heights. So we've provided velocity at different heights, we've provided the mass in a separate column, and we've provided the acceleration due to gravity. And we're going to use these to help reference and make our calculations. So if you remember, GPE is mass times gravity times height. So to do this first cell, what I'm going to do is I'm going to say equals. I'm going to click on my mass over here. So I'm literally going to move my mouse and click on it, and you'll notice it now does a cell reference over here. By cell reference, I mean it says, hey, look, we're going to say equals the cell G4. Well, this is row 4 and column G, so that would be G4. We then say times. Times is a shift and then 8. That is the asterisk symbol, and that's how you do multiplication in a spreadsheet. And then we have mass times gravity, so we'll click on gravity. Notice it's referencing cell H4, which is just one column over here. And then we say times, and we go back over here and click on height, which is in our column A. So what this should look like inside your cell is G4 times H4 times A4. You hit enter, and you notice that it went ahead and did that calculation. Now, if the autofill suggestion pops up and you want to use that, feel free. It will basically repeat that same calculation over and over and over for you. So what that means is it said, oh, you just wanted to multiply this column G times column H times column A for each of these separate rows, and it goes ahead and does that. So it recognizes that on each row you probably want to move down a row for all of them, and so it does that over and over and over again. If it didn't do autofill for you, I'll delete this real fast. You can kind of skip ahead to the next marker, but we'll go through doing the actual calculations here. So we're going to do this again. We're going to say equals, then we're going to click on our mass, that'd be G5. We're going to say times, we'll click on our acceleration, and then we'll say times, and we click on the A value, or in this case, the height. We hit enter, and it does that calculation again. And we'll do this again, equals, and then we say, oh, look, and it's trying to learn what our pattern is for us. Hopefully it's already doing that for you, but we'll go ahead and say equals G6 times H6 times A6, enter, and then we do that again. We say equals, and hopefully with all of these kind of new AI and autofill predictive tools, it's kind of guiding you along the way on what to do. It's good to just practice typing it in a few times just so that you can get more comfortable. Now, we've done this 3 or 4 times at this point. If you haven't done an autofill, one trick you can do is you can highlight something where you've used the kind of the same pattern or formula. Notice our pattern was always the G column times the H column times the A column. Well, what you can do is highlight it, and then you grab the little blue dot, or sometimes it's a box down at the bottom. You grab it after it turns into a crosshair for your mouse, and then you drag it down, and what it does is it fills down for you. So before, when it was asking to auto fill down, it was basically asking, oh, do you want us to do this filling down action that people often do? You can manually do it at any point, even if it doesn't auto do it for you. Cool. So that means we now have all of our GPE. Next, let's go ahead and get the kinetic energy. So we're going to follow that same process, only this time instead of typing in the mass times gravity times, so we're not doing mass times gravity times height, and this time we're doing 1/2 times mass times velocity squared. So I'm going to type in equals, I'm going to type in 0.5 for 1/2. You could also do 1 divided by 2 in parentheses, just to make sure you got the order of operations correctly. And then you say times, and then we say mass, and then we say times, and then we click on the velocity, but we need to square it. So you do a shift and then 6, and that will put that little caret symbol in there. Again, that was shift 6, that puts the caret symbol there. And then to square it, you would say 2, so that would be to the square power. Alternatively, you could just multiply it times F4 one more time, because that's what squaring is. When you're done with that, you hit enter. Maybe it asks you to autofill. Feel free to do that. I would encourage you to practice typing a equation in a couple of times just so you actually get some practice and then do some autofill, or maybe you go back and delete a few of them and then do autofill. But I'll go ahead and demo what you can do right here. So we go equals, we go 0.5, we say times, we click on our mass over here, we say times, that's the shift and then 6, and then we click on the velocity right here, and then we need to square it, so we do the caret symbol and then say 2. Sorry, times was shift 8, not shift 6. So the asterisk or times is shift 8, and then the caret symbol is shift 6. I got ahead of myself. Hit enter. Cool. And then we do that again. It's equals 0.5 times, and then we click on the mass, and then we say times, and then we click on the velocity, and then we square it. Cool. And then at this point, if you've typed it in a couple of times and you're ready to fill down and it's not asking you anymore, then what you can do is highlight those cells. To highlight, you click and drag to highlight. And then you grab the blue circle down here. You'll notice that it turns into a little crosshair symbol instead of a typical pointer symbol. So when it turns into a crosshair symbol, you can then click and drag and bring it down, and it will fill in those formulas. So here what we notice is that as we've gone along, it's taken the column 1/2 times column G times column F F squared is what that's calculating. Cool. Next bit, we're going to do the total energy. Now, think through for a second, maybe pause the video. If we have GPE and we have kinetic energy, how do we find the total energy? What do we need to do? All right, welcome back. Hopefully you realized that to find total energy, you just add those two together. So for here, what we're going to do is just add column B to column C. So I'll say equals, and then I will go ahead and say column B, and then I will say plus, and then I will say column C, and then I will hit enter. I'll do it again, equals. I click on column B, I say plus, and then I click on column C, and then I hit enter. I'll do it again, equals, I'll click on column B, I'll say plus, I'll click on column C, and then I'll say enter. If you want a different way of doing this, the other function you could use is the sum function, and it actually suggested that in the beginning. You can say equals sum, SUM, like addition, you do parentheses, and then you highlight the two things you want to sum, you close the parenthesis, and it will also do the same thing as if you did the plus and plus. And that way you can highlight multiple things in a row. All right, so at this point, I'm going to highlight these. I'm going to fill down my formula by dragging down that little dot. And now we've got our total energy. All right, now we've got our GPE, we've got our kinetic energy, and we've got our total energy at various heights for an object that was thrown up in the air. The next thing we're going to do is we're going to scroll down too much, and we're going to make an energy height scatter plot with the three energies. So what I do is I'm going to click over here just so that we can put our graph there. I'm going to go to Insert. I'm going to, oh, nope, I need to highlight my data first. I apologize. All right, so what I'm going to do is I'm just going to highlight the part that's boxed right here. So I go ahead and I highlight all of that information. And that way it knows that's the thing I want to graph and not all these other things over here. So I now go to Insert, and I'm going to go to Chart. And it naturally wants to do a bar chart. We will do a type of bar or column chart later. For now, we want to change this to a scatter plot, which is the type of graph we tend to use in physics. You would think it's a line graph, but line graphs don't show you points. It just kind of connects the dots for you. What you want is a scatter plot. We always plot individual points, and then we later on add in our trend lines or lines of best fit. Cool. So next, you can change the title real fast if you want. So you can say GP, KE, and total energy for objects. So we'll say 5 kilogram object thrown into the air. Cool. Next, I'm going to go ahead and drag this down. So I click on it and I drag it to put it into the spot where we're working on it. And I'm going to go ahead and shrink it down just a little bit so that I can kind of make it fit my space here. You might not need to, but I do in this scenario. So I'll shrink it down just a little bit, or maybe I'll leave it big and then I'll shrink it down after we finish. That's what I'll do. Okay, so we need to do a few separate things. Notice here that we have 3 different graphs going on. We have this total energy graph that is in yellow up top. We have our kinetic energy graph that is in red, and then we have our GPE graph that is in blue. What we're going to need to do is add a trend line. So to do that, I'm going to go to Edit Chart. So I go to those 3 dots. I go to Edit Chart. And then here I go to Customize. And I'm going to go down here to Series. And what I'm going to do is I'm going to tell it I want to add a trend line. Now, I had already said for it to apply to all series, but if for some reason you needed to apply different types of trend lines, you might want to go through each individually. So you might choose gravitational potential energy, and you say add trend line, and then you would say, okay, I want a linear trend line. And for the label, I could then say use equation. And so what that would do is now I'm able to see what my trend is or what my kind of pattern is for that line, as well as the equation for it. Now I can do that same thing for all of them. So I'm going to actually just go ahead and say apply to series. Since they're all linear, this ends up working out a little bit quicker and easier. For all of them, I'll say use equation as the label. It doesn't seem to be registering that, so maybe I'll go to custom and then I'll go back to use equation. But it doesn't seem to want to do that for all of them. So let's go ahead and do this individually. So kinetic energy, trend line, linear, use equation. I'll scroll back up, and then now I'll change this to total energy. I'll scroll down, and I'll go to label and use equation. It might shift your equations over here. That's totally fine. If you don't like how big that is, you can always resize some of the things, and that is fine. And so now what we have, I'll make it so it all fits on one line. There we go. Now we have our 3 trend lines. We've got, we see that the total energy is there up top in yellow. We've got that the red trend line here shows us the kinetic energy, and we have the blue trend line showing us the gravitational potential energy. We can see that as we go forward in time, as the height changes, as it goes from 0 to 1 to 2 to 3 to 4 to 5, we have that the energy also changes as well. Now, when we originally graphed this, I think it had that it went all the way back down. Notice that those points are exactly the same at the same heights as it was before. So what that means is our graph actually kind of doubles back on itself a little bit, and that's why we kind of see it doing that. Surprisingly, it did not make too much of an error in the graphing. So You can take a look at those equations that are there. We can see that they're basically the same, just opposites. Here it's a plus 50, here it's a minus 50, and here this is effectively 0 is what's going on, where we have that the total energy is constant and flat. And I think you're going to be answering some questions about the trends or patterns in a few steps.